And really the tenets of behaviorism were that all behavior is explained through learning. The mind doesn't matter. It's a black box, and all the experiments we talked about where we revealed the cognitive abilities of dogs, people who are arguing for behaviorist approaches to animal psychology have long argued that the experiments that I've showed you really aren't powerful, and we can't really understand the animal mind. It's a black box. We can't see inside of it. And all we can measure is the stimulus that leads to a behavioral response in trying to determine how animals behave. And that's why classical and operant conditioning were used as such powerful mechanisms to explain behavior, because it was obvious that you could create a stimulus and get a potential response without having to worry about what was going on inside that black box. The other argument was that all animals learn via the same simple learning mechanisms. It didn't matter what species you were talking about. And so this is very different than thinking about different types of intelligence and different types of species. Really, it's just all animals learn through classical and operant conditioning. And the only real difference is that species and individuals can vary in the speed by which they learn. But really, there's just one thing to measure, and that is the ability to learn through these mechanisms of classical and operant conditioning. So, of course, that is in absolute diametrical opposition to a cognitive approach where we argue there are different types of cognitive abilities and species really different, individuals different, and that you need to understand an individual's cognitive profile. But that doesn't mean that a cognitive approach doesn't think that classical and operant conditioning are really important. So let me say or describe how classical and operant conditioning would fit in taking a cognitive approach, which is that all behavior is explained by taking a cognitive approach, and especially taking an ecological perspective on the presence or the design of cognition. And classical and operant conditioning are absolutely important mechanisms that animals use to learn in some context. But at the same time, learning is just one among dozens of cognitive mechanisms. There's lots of other things that we've talked about. Animals learn socially. They can read intentions in some cases. They have temperament and motivation. They have social memory. They have object permanence. There are all sorts of things that they do besides just classical and operant conditioning. And between modern neurobiology and the cognitive sciences, those things have become measurable, even though animals can't speak to us. So the mind does exist, and it represents goals and memories, etc. And it helps us decide between behaviors without, in many cases, directly perceivable information. And species and individuals evolve to vary in cognitive flexibility and vary in different ways depending on what type of intelligence you're talking about. So can we use this ecological approach to cognition, which I think is really different than the approach that behaviorists espoused, where I think a lot of the ideas about animal training came from and have been applied very successful in many cases. The question is, can the ecological approach to cognition take us even further? And I don't know the answer, but here's some ideas about how we might think about the ecological approach to cognition as it applies to training. So the first thing to understand is that if you understand the ecological context in which a species evolved, you can recognize ways in which cognition of an animal or species might work for you. So in the case of dogs, there's some really beautiful studies looking at how dogs deal with detours. And here's a fence, and this is actually a drawing of an experiment that was run by Adam Miklosi's group in Hungary. And he simply put a treat, and you can sort of make out the bone behind the fence there. He either put a treat or a person behind a fence, and it was very simple. The dog just had to go around the barrier to get the bone. Well, when most dogs were given this problem, they spent a lot of time running back and forth around the fence. They didn't go around the detour immediately. They would stand near the person or the bone, behind the fence, bark, dig, run back and forth, and not realize that just all they had to do was go around. Eventually, they would slowly learn that they could go around to solve this problem. Now, when wolves were given this problem, and really the best comparison of wolves and dogs was done by Frank and Frank in the 80s, but when that was done, what was seen was that wolves, given this type of non-social problem of going around a detour, they very quickly, relative to the dogs they were being compared to, solved this problem. They did make some mistakes, but over each repetition, they got quicker, faster, and when they were given a new barrier, they were able to generalize and apply that to solving the next problem, whereas dogs really struggled no matter what you did. And here was the interesting work of the McCloskey group. They made it social. And as soon as they made it social, dogs absolutely solved this problem immediately. Something that was incredibly difficult for them to solve on their own becomes very easy as soon as they see a person or another dog go around the barrier before them, and they actually see that the barrier can be rounded and that it can be circumvented. Then on their very first attempt, they go almost directly around the barrier and get the object, the target item that they were trying to obtain without making any mistakes whatsoever. So you go from an animal that looks absolutely bamboozled, cannot solve the problem independently on their own, to an animal with one social demonstration on their first trial can solve this problem, and it makes it look elementary. Wolves did not solve the problem as well when they saw a human demonstrator, and that's one of the fun things, is that dogs really seem to be unique, and this is where they're remarkable, in learning from people in a social way. As soon as you make a training activity social, a problem where with their own experience they can't learn, they can generalize from watching others to their own behavior much, much faster in a number of contexts. So it's something, if you're training a dog, you might want to think about. Is this something we could make social and a dog might learn faster? So while cognition, and particularly the social cognition of dogs, can potentially work for you, what about cognition working against you? Well, here's another great example, is a lot of training is about repetition. And the more that you repeat a behavior or a behavioral pattern, it should be the better that an animal gets at solving the problem.